Okay, hello students, we're back again. Identifying functions from numerical patterns. Last video we learned about the add property of linear functions. Well, what about quadratic functions? You could kind of see that this is increasing, but it's hard to see. Okay, so once again, this is the same example that we had, page 2. So this is the same example we went through in class. Notice the data set, 1, 3, 5, 6, 4, 18. 1, 3, 5, 6, 4, 18. Here, let me just move this over. Here, we only need 3 points because we have 3 unknowns in the general equation. So we need 3 equations. And then once we have our 3 equations, we can search for a system of quadratic equation solver, and that will solve this system of 3 equations. You can also do it by hand, and there's calculator techniques. However, our focus is on finding a particular equation for identifying functions and then finding the particular equations and see if our algebra was correct by graphing and see if it goes through the points. So here, now what about if we just have a set of data, numerical values? Okay, notice here, let's see what happens from 1, 2, 3. I am adding 2, right? From 1 to 3. And how about from 3 to 5? I'm also adding 2. Okay, so it looks similar to the add. Maybe this is the add property. I'm not sure yet. So, okay, how about from 5 to 7? Yeah. And we want to check the entire data set, just to be certain. From 7 to 9. And you could, at least in this part, you could probably just visually verify it, right? Okay, now how about from 6 to 4? Let's see. I'm subtracting 2, minus 2. Oh. What about from 4 to 18? From 4 to 18, I am, what is that? 4, 18, 12, right? So I'm adding 12. So from 4 to 16, I'm adding 12. Okay, this doesn't make any sense now. Okay, what about from, so from 6 to 4, I'm subtracting 2. From 4 to 18, I'm adding 12. Let's see. Here, from 18 to 48, 48, 38, 28, 29, 30. 48 minus 18, so I'm adding 30 plus 30, and then from 48 to 94, 46, I'm adding 46. Okay, so definitely not the add property. So this is not a linear function. Well, is there something else? Is there another property? Well, we already know this is quadratic because this is the same example. But let's take a look at what happens at what's called our second difference. So here, this is from here, from negative 2 to 12, I am adding 14. From 12 to 30, I am, let's see, what's 30? 18. Okay, so this video is totally messed up right now. Let's see here. Let me see. Negative 2 to 12 is plus 14, right? Minus 2, 4 to 18. Oh, no. Okay, so let's back the truck up here. this here, 18 minus 4. 18 minus 4, I thought it was 12. It's 14. Yes. And then 18 minus 4 is 14, right? So I'm actually adding 16 here. And then from, let's put this on here. From 14 to 13, I'm adding 16. And then from 30 to 46, I'm adding 16. So this video isn't totally messed up. We've saved it. So on the left-hand side, we are add. On the right-hand side, we have what's called a constant second difference. Okay, so let's just summarize this now here. So this is called the constant second difference property of quadratic functions. So what this means now is that we can go to our other example. So now here we can visually see this is parabolic shape. It must be quadratic. We assumed it was quadratic. So now we can use now this is the general equation that we would use. And we would go about the process that we talked about in class. We would create three equations. So now which 3 points should we use if we have well, like you said, we can use any 3 points. First of all, we're going to use y equals ax squared plus bx plus c. That's our general equation for a quad. This is the general equation. Let's see. So use the general equation for a quadratic function, which is what we just wrote. And what 3 points should we use? Well, x1 comma y1. You can use the same three, just use the first 3 points, right? 1 comma 6. Oops. 1 comma 6. And let me copy this. And so you have 3 equations. So you have 3 unknowns, A, B, and C. So you need 3 equations. In order to create 3 equations, you need 3 points. You need x, and that's why we have x1, x2, y2. And we'll make that the second point, 3 comma 4. And the third point will be 5 comma 18, just exactly like your the example when we were identifying the quadratic functions from graphs, from graphical patterns. So here we identifying quadratic functions from numerical patterns. Okay, so I'm not sure why this is going so slow. Okay. And so your y1, right? y1 equals a times x1 squared plus b x1 times x1 plus c. And your 2 other equations are going to be